All right, take 4. Lesson 4.6. Prove triangles congruent by angle, side, angle, and angle, angle, side. So far, you should be familiar with side, side, side. You should also be familiar with side, angle, side, and hypotenuse leg, which works only for right triangles, not all right triangles, but it only works for a right triangle. All right, so take a moment, copy down these triangles here, and then we're going to use our given information and we're going to talk about it, okay? First, it tells us triangle A is congruent to angle D. Then it said side AC is congruent to side DF. And angle C is congruent to angle F. Notice I have an angle, I have a side, I have an angle. It even works if I go the other way. I have an angle, I have a side, I have an angle. Okay, so the side must be between the two congruent angles. So triangle ABC is congruent to triangle DEF by the way of angle, side, angle, postulate. Boy, my handwriting is getting worse as the day is going on. All right, let's check out angle, angle, side. Angle, angle, side is actually a theorem. It's already been proven, so you can assume that it's true. All right, so let's first off copy down these triangles on your paper. And then here's my given information. If angle A is congruent to angle D, just like the last one, then we have angle C is congruent to angle F. I'm going to make sure that you don't use the same number of marks because I can't say that that A and C are congruent to each other. Okay, I'm only using the information I'm given right here. Then it also said side BC is congruent to EF. Now, if we look and see what we have angle, angle, side. If you went the other way, side, angle, angle, you're going to be like, I don't know if that's a theorem because there's so many A's and S's. But what I want you to do is go to page 250 in your book, and there is a pretty cool graphic that is a summary of the 5 congruency theorem / postulates that we're going to use for these triangles. Okay, so familiarize yourself with them if you need to make note cards or whatever, but just take the time. Okay, so first off, now we know that we have an angle, we have a side. This is congruent triangles by angle, angle, side theorem. So triangle ABC is congruent to triangle DEF by angle, angle, side. All right. Let's see if we have enough information to prove some triangles are congruent here. So first off, it tells us AD is parallel. That's what this means, parallel. Parallel. All right. So that tells us some things about the angle relationships, right? Remember alternate interior angles, right? So I have D is congruent to C. Alternate interior. And then what else does it tell us? Okay, so it says that side BD is congruent to BC. BD is congruent to BC. I see angle B here is congruent to itself because it's a vertical angle. Vertical. I'm just going to abbreviate. All right, so now I have an angle, I have a side, I have an angle. So this is angle, side, angle. I want to point something else out to you, not to make it more confusing, but notice that angle A is congruent to angle D because they are also alternate interior. I didn't need to do this because I already proved it was congruent using a side angle, but if you see here now, I have angle, angle, side. So that happened too, angle, angle, side. So if you saw that before I started talking about this, that's fine. So there's sometimes two triangles are congruent more than one, it's true for more than one theorem or postulate. That's what I'm trying to say. Okay. Let's look at these bad boys here. All right, so now let us separate these two triangles, okay? So we have this here. This is A, B, D. And then we have C, this is A, and this is B. All right, well, we know AB is congruent to AB because they're vertical angles, right? I mean, not vertical, that was silly. They're reflexive sides. They share the same side, that's reflexive. So AB is congruent to AB. And then in the image, C is congruent to D, that's given information. All right, so now, well, angle A has to be congruent to itself, as so does B. Okay, so now I have either angle, angle, side, or angle, side, angle. You could go either way with this one. We'll just go angle, side, angle. I guess I'll write or angle, angle, side, whatever. Angle, angle, side. All right, I didn't write I just wrote these, this is my theorem or postulate. I didn't write any of my other stuff down, okay? So here I have another pair of triangles. Remember that these little marks mean that BC is parallel to AD. So maybe we do want to make a note of that. BC is parallel to AD. When you have parallel lines, you're going to have alternate interior angles of some sort, usually. I shouldn't always generalize that, but this and this, they're alternate interior. Angle A, alt, int. Okay, and then we know AC is congruent because it's reflexive. Reflexive. Again, I'm going to just abbreviate. And now, do I have enough information, right? I have a side, an angle, and a side. So, side, angle, side. It's got the SAS. Or if you had your other set of alternate interior angles, like I added on that other one here, right? For the same reason, I'm just going to put a blue star here because I don't need to write it twice, or I clearly see that. But now, did that really help us at all? Perhaps it did, because now I have an angle, a side, and an angle, all with the same triangle, or angle, side, angle. So sometimes there's more than one, sometimes there's none, so be on the lookout. Okay, so here's your assignment for today. Assignment number 21 on page 250, number 3 through 7, and 18 through 20. If you have any questions, hit me up on Schoology. Have an awesome day. Bye.